Alright, in this video we're going to finish up this test review, look at the last few questions. Here on question number 9, we're asked to find the derivative of sine x squared over x. And so to start out, we need to ask ourselves, what derivative rules do we need to use? This is power, product, quotient, or chain. And we've got a quotient here. We can see the division, and I notice that there's an x in the numerator and in the denominator, so we're definitely going to be using the quotient rule. But in the numerator, I see we have sine of x squared, which indicates a composite function, and so I'm going to need to use chain rule as well. So I'm going to rewrite the function down here. Numerator is f, denominator is g, and before I start to find to apply the quotient rule, I'm going to go ahead and determine f prime and g prime. So to find f prime, this is the part of our function that where we need to use the chain rule. I've got a two-layered composite function there, sine of x squared. So I'm going to set up my chain rule chart. Sine of something, and then x squared. The derivative of sine is cosine of something, and the derivative of x squared is 2x. And so my f prime, cosine of x squared times 2x. And so now let's find g prime. This, of course, is much simpler. The derivative of x is 1. So now we're ready for the chain rule. I'm sorry, not the chain rule, the quotient rule. And our quotient rule, write it over here for reference, f prime g minus g prime f over g squared. So my f prime is cosine of x squared times 2x times g, which is x, minus g prime, which is 1, times f, which is sine of x squared. And of course this is all over g squared. Now if I stop here and look at my answer choices, I don't see anything up there that matches what we have. So we're going to have to do a little simplifying here. But I think I can safely eliminate answer choice A and answer choice E. And I'm noticing that answer choice B is really close to what I have, but it is missing this 2x times x there in the first term. And so I think I can safely eliminate this answer. So I'm left with these two choices, C and D. And I notice in these two that the x squared as a denominator is only there in the second term. That indicates to me that to do this simplifying, they have split up the numerator, separated those terms, both of them over the same denominator. So let's do that and see what happens. I have cosine of x squared times this 2x times x. I'm going to go ahead and multiply those together and get 2x squared. We're going to put that over x squared minus, for this term, I have sine of x squared over x squared. Now, here on the left, I see that we can cancel out or divide out the x squared and x squared. Those divide out, just leaving me with 2 times cosine of x squared. Now I cannot cancel out this x squared and this one because my x squared in the numerator here is inside the sine function. So it's not being multiplied, which means we can't undo it with division because it's inside the sine function. And so that fraction needs to stay as it is. But I believe with that simplification, we see that we've got answer D. All right, let's move on to the free response question. We have a piecewise defined function f of x, and in part A, we're asked to use the definition of continuity to show that f of x is continuous at x equals 0. Now to do this, we need to show all 3 parts of the definition of continuity, show that all 3 of those things are true, that the limit as x approaches a exists, that f of a exists, and that those 2 values are equal to each other. So I'm going to start with the limit. And in order to show that the limit exists, we need to show that the limit from the left is equal to the limit from the right. So the limit as x approaches 0 from the left of f of x is going to be equal to, and I'm going to plug in 0 into the part of the function that is approaching 0 from the left. That means where x is less than 0. And so that would be the first piece, so e to the negative 4 times 0, which would be, of course, e to the 0, which is 1. And now to find the limit from the right, limit as x approaches 0 from the right of f of x is equal to 1 minus 2 times sine of 0, which is equal to 1 minus 2 times the sine of 0 is 0, and so we get 1 minus 0, which is 1. So the limit from the left does equal the limit from the right, and therefore we can say that the limit as x approaches 0 of f of x is equal to 1. And so we have verified that that limit exists. So now let's move on to show that f of a exists, in this case f of 0. And if I'm going to find the value of the function at 0, I want to look for the piece that includes 0, which again would be this top piece where it says x is less than or equal to 0. So e to the negative 4 times 0, which again would be 1. So that value exists. And both of these values are equal to 1. And so we can say that the limit as x approaches 0 of f of x does in fact equal f of 0. And so we've shown all three parts of the definition of continuity. And therefore, f of x is continuous at oh, nope, I didn't spell that right. I didn't think it looked right. Continuous at x equals 0. All right, let's move on to part B. Here in question B, we're asked to find f prime and to write it as a piecewise defined function. This is not something we've done in class before, but it was a step that I was hoping we could look at this, and a new step that we could take. F prime is going to be equal to, we're just going to take the derivative of each piece separately. So in my first piece here, e to the negative 4x, I look at that and I see we've got a chain rule. It is a two-part chain. So I'm going to set up a little chain rule chart here. E to the something is negative 4x. Of course, the derivative of e to the something is just e to the something. The derivative of negative 4x is negative 4. And so this part is equal to e to the negative 4x times 4. And so that would be the derivative of my first piece. I'm going to move that 4 into, I'm so sorry, that should be a negative 4. So negative 4e to the negative 4x. And that is for x less than or equal to 0, the same domain piece as the original function. Now for the second part of the function, when I look at that, I see that we just have, we just need to use the constant rule and the derivative of sine, just one of the trig rules. No power rule, no product rule, no quotient, no chain. So the derivative of 1 is, of course, 0. And the derivative of negative 2 sine x is going to be negative 2 cosine x. And that is going to be true for x greater than 0. And so there you have f prime of x as a piecewise defined function. All right, in the last part of this question here, we're asked to find f prime at pi over 3 and then write the equation of the line tangent to f of x at x equals pi over 3. So we're asked here again to write the equation of a tangent line. And in order to do that, I need to know, I need to find a value for a, I need to find a value for f of a, and I need f prime of a. Now here in the question I can see that a is pi over 3. To find f of a, well, that's going to be f of pi over 3, which means I need to substitute pi over 3 back into our original function. And I need to choose which piece to use here. Pi over 3, is it less than 0 or greater than 0? Well, of course, that's a positive number, so that's greater than 0. So I'm going to sub into the second piece. So that's going to be equal to 1 minus 2 times sine of pi over 3, which is 1 minus 2 times the sine of pi over 3, which is square root of 3 over 2. And those 2's will divide out, and I'm left with 1 minus the square root of 3. So I have my f of a value. Now all I need is the f prime of a value. So I need to find f prime at pi over 3. And to find that, I'm going to substitute into the derivative function, which we found in part B. Pi over 3 is still in the greater than 0 piece, x greater than 0, so I'm going to substitute into that piece of our derivative, negative 2 times cosine of pi over 3. And this is equal to negative 2 times 1/2, which of course is negative 1. So now I have all three values that I need for my tangent line equation. I'm going to write the formula down for us one more time. Y equals f of a plus f prime of a times x minus a. And so y equals f of a. That value was the 1 minus the square root of 3 plus f prime of a, which we just found to be negative 1, times x minus a. That a value, of course, is pi over 3. And we can leave our answer right there in that form.